Okay, so in this lecture, I want to discuss some problems where we're asked to determine equilibrium constants. And these will all be an aqueous solution. So please recall that in aqueous solution, pure water, the autoionization of water occurs with a Kw value at 25 degrees Celsius of 10 to the negative 14. So that Kw describes the amount of products relative to reactants when two water molecules react together. One acts as an acid, the other acts as a base. That produces hydronium, the conjugate acid of water, and hydroxide, the conjugate base. And this equilibrium constant here, Kw, is equal to the aqueous products, and their concentrations are multiplied. So we omit water from that equilibrium expression because it's a liquid. And of course, these two will multiply to give 10 to the negative 14. Or in pure water, you'll have 10 to the negative 7 molar of hydronium and an equal concentration of hydroxide. So those multiply to give Kw. Right, so that proves why the pH of pure water or negative log of hydronium is 7, because there's 10 to the negative 7 molar hydronium and hydroxide in this solution or in this solvent. So let's take that Kw and do some problems where we have to manipulate it to find new equilibrium constants. For example, if you want to find the equilibrium constant for the reaction between hydronium and hydroxide to form two water molecules. So if you look at the above equation, hydronium and hydroxide were products for Kw. Now they are reactants for the following reaction. Whereas water molecules were reactants for Kw, and now they are products. Okay, so this is the inverse or the reverse of the autoionization, which means the equilibrium constant here, Kq, should be the inverse of Kw. 1 over 10 to the negative 14 gives 10 to the positive 14. So while the autoionization was very much reactant favored because Kw was much less than 1, now this reaction is going to be product favored since 1 over Kw is much greater than 1. And simply remember that flipping a reaction where the reactants become the products and the products become the reactants means we take the inverse, or 1 over Kw is that equilibrium constant. In other words, 1 over Kw, which is Kq here, is equal to 1 over aqueous hydronium concentration multiplied by hydroxide.